Imagine a time when the universe will dissolve into absolute blackness. There will be no stars, no warmth, and no movement, just an eternal, cold silence consuming all of existence. I invite you to explore the concept of quantum winter, the ultimate destiny where all useful energy is spent and the cosmos enters a permanent deep freeze. We will investigate how the universe arrives at this final state and what it signifies for the last remnants of matter and life on this journey to the very end of time. Quantum winter is a theoretical future state of the universe governed entirely by the principles of quantum physics. For many, quantum physics can seem intimidating and confusing, yet this field of science is essential for grasping how the universe operates at its most fundamental level. Far from being an abstract discipline with no bearing on your daily life, quantum mechanics is actually the foundation for much of the technology you use, including everything from lasers to mobile phones. It is remarkable to consider that the peculiar rules of the quantum world are what power these modern devices. Think of the universe as an immense puzzle, with each piece signifying a part of reality we are trying to comprehend. Quantum mechanics offers us the framework to put these pieces together, unveiling connections and patterns that would otherwise be invisible. Within this cosmic puzzle, quantum winter may represent the final piece, potentially holding the key to unlocking the universe's most profound secrets. The cosmos has a story to tell, a narrative that begins at its very creation. Are you aware that the entire universe originated from a colossal explosion we call the Big Bang? In that singular moment, every bit of matter and energy we can observe today erupted from a point of infinite density. It is a staggering thought that such cosmic vastness could emerge from something so small. The elementary particles forged in that instant laid the groundwork for everything in existence. But to trace their journey, we must venture into the quantum realm. Quantum mechanics consistently defies our everyday intuition. In this subatomic world, particles can exist in many places at once and can influence one another instantly, no matter how great the distance between them. The idea of being in two locations simultaneously may sound like fantasy, but it is a documented reality for quantum particles. This strange behavior compels us to reconsider whether our perception of reality is as simple as it appears on the surface. Now, let's examine the quantum vacuum, a concept that seems like a contradiction in terms. In the quantum universe, even a perfect void is alive with energy and possibility, as particles can spontaneously appear and then vanish, like fleeting bubbles in an ocean of potential. These constant quantum fluctuations are thought to be the very seeds from which all matter and energy originally sprung. What if I told you that in the moments immediately following the Big Bang, the universe expanded at a rate faster than the speed of light? This theory, known as cosmic inflation, suggests that this rapid stretching event is what smoothed out the cosmos and established its large-scale structure. The vast and intricate web of galaxies and stars you can see in the night sky today is a direct consequence of that primordial expansion. When we consider the structure of the cosmos, it's essential to address the mystery of dark matter. Did you know that the majority of the matter in the universe is completely invisible to us? This elusive substance emits no light or energy, but its gravitational pull is crucial for holding galaxies together. Without this unseen scaffolding, the universe as we know it would simply fly apart, leaving us to wonder what secrets this invisible matter holds. Another great cosmic puzzle is dark energy, the mysterious force believed to be causing the universe's expansion to accelerate. Comprising roughly 70% of the cosmos, dark energy's true nature remains one of the most significant unanswered questions in science. It is a profound mystery how a force so dominant and widespread can remain so completely undetectable to us. As we contemplate these cosmic forces, we must also consider the principle of entropy, which dictates that disorder naturally increases over time. For the universe, this implies a slow but inevitable descent towards a final state of maximum equilibrium. This potential fate, often called the Big Freeze, is a future where everything cools down and dissipates, forcing us to reflect on the ultimate destiny of all that exists. This journey of discovery leads to even more profound questions, such as the information paradox. Physicists grapple with what happens to information that falls into a black hole, as the idea that it could be preserved under such extreme conditions fundamentally challenge our understanding of reality. This question continues to fascinate and perplex scientists and philosophers alike. The idea of parallel universes further stretches the limits of our imagination. What if countless other realities exist, each one branching off from every decision ever made? This is the core concept of the multiverse theory, which posits that our universe is just one among an infinite number. Acknowledging that endless versions of yourself could exist would radically alter your perception of the world. Finally, concepts like string theory and quantum entanglement push these boundaries even further, suggesting that all the fundamental forces of nature might be interconnected within a single cosmic fabric. This vision invites you to perceive a universe where everything is profoundly linked, with particles interacting in ways we are only just beginning to grasp. As we delve into these topics, we are confronted with questions that challenge us to consider our own place in this immense and mysterious cosmos, reminding us that science is a journey of endless exploration. Imagine the Big Bang as a single spark ignited in an endless void. From that one explosive moment, the entire universe we recognize, with its immense space and flowing time, was born. In the immediate aftermath, the very first fundamental particles, such as electrons and protons, materialized almost instantaneously. These are the essential components of all matter, and without them, atoms could never have formed, meaning the tangible world you see around you would simply not be here. It's truly remarkable to think that the nascent universe was a place of such intense heat that particles were unable to join together into atoms. It was essentially a turbulent sea of pure energy. Just try to picture a reality where matter, as we know it, couldn't exist, only this roiling, energetic state. As the cosmos expanded, it began to cool, and eventually the environment became right for electrons to finally bond with protons, creating hydrogen, the most fundamental and plentiful element in existence. So, how did this universe of hydrogen give rise to stars and galaxies? With this raw material now available, the cosmos embarked on the path toward creating more intricate structures. The familiar yet enigmatic force of gravity, which anchors you to the earth, began to draw these hydrogen atoms toward one another. Think of it as a giant cosmic broth, where ingredients slowly swirled together, as these immense clouds of gas eventually collapsed under their own weight, igniting the very first stars. The emergence of these pioneering stars was a pivotal moment. Inside their fiery cores, a process known as nuclear fusion acted like a celestial forge, creating heavier elements such as helium and carbon. But when these massive stars depleted their fuel, they met a spectacular end, erupting in cataclysmic explosions called supernovae. These events blasted the newly forged heavy elements throughout space, seeding the cosmos with the materials from which life, as you and I know it, could eventually arise. While the universe carried on with its expansion and cooling, the initial galaxies started to take shape. You can envision these immense structures as sprawling cosmic cities, each housing billions of stars, planets, and countless other celestial objects. Gravity was once again the principal architect in this intricate and captivating process. You might wonder how we've come to understand this epic history, and the answer lies in scientific observation and theory, which have allowed us to assemble this cosmic timeline, even as many profound questions still await answers. These unresolved mysteries naturally lead you to contemplate your own position within this vast universe. If all of existence emerged from the Big Bang, and your body is composed of the very same elements forged in stars, it profoundly deepens your connection to the cosmos. You are the product of billions of years of cosmic development, which means the night sky is more than just a beautiful sight. It's a direct reminder of the history you share with everything out there. The realization that the very atoms constituting your body were once forged inside a faraway star is truly mind-boggling. In a very real sense, we are all made of stardust. This powerful concept encourages you to gaze at the heavens and wonder what other secrets it holds. The cosmos is immense and teeming with enigmas, and despite the incredible progress we've made in our comprehension, we've barely begun to explore its full extent. This investigation into our cosmic beginnings is an odyssey with no final destination, as every new finding only opens the door to more questions and fresh curiosities. What other discoveries are waiting for us, and what truths are still concealed within the infinite void of space? The pursuit of these answers compels us to continue our exploration and learning. As we contemplate the Big Bang and the emergence of the first particles, it's worth remembering that you are part of an immense, shared story that started eons ago and is still unfolding. Comprehending the universe is more than a scientific pursuit. It's a call to stand in awe of the sheer scale of everything around you, where every star contributes a chapter to the epic that helps you find your place in the cosmic drama. Now let's delve into an even more perplexing realm: quantum mechanics, a maze of concepts that defies all common sense. What if I were to tell you that a single subatomic particle can be in many locations simultaneously? This isn't a fantasy. It's a fundamental principle of this field, which forces us to completely reevaluate our perception of the universe and reality itself. Think about the behavior of objects in your daily life. If you toss a ball, you can predict its trajectory and landing spot with certainty. In the quantum domain, however, particles act more like elusive shadows, with their positions and states fluctuating in ways you cannot foresee. This bizarre nature enables scientists to investigate phenomena that contradict our everyday logic, where particles can materialize and vanish, and their very existence seems to hinge on the act of observation, much like performers who only exist when someone is watching. So, how does light fit into this strange picture? It turns out that light isn't merely a wave propagating through the cosmos. It also acts as a stream of discrete energy packets called photons. This concept is called wave-particle duality, and if you've ever been puzzled by how light can traverse the emptiness of space yet still create a distinct shadow, you've grasped the core of this quantum mystery. Much like other subatomic particles, light's behavior is not rigidly fixed or easily predictable. Furthermore, quantum mechanics presents the uncertainty principle, which establishes that you can never know both the precise location and the exact momentum of a particle at the same time. This is crucial because it shatters the classical idea that everything can be perfectly measured. The quantum realm imposes fundamental limits on what we can know. This leads to the concept of superposition, which states a particle can be in multiple states simultaneously. To visualize this, imagine a spinning coin. Until it lands, it's not heads or tails, but in a state of being both. And that is the core idea of superposition. When a coin is tossed, a single result becomes certain only after it lands. Until that moment, it embodies the potential for either outcome. This principle is a cornerstone of quantum mechanics, revealing a universe rich with possibilities. Take, for instance, the double-slit experiment, where a particle behaves as if it passes through two separate openings at once, generating an interference pattern akin to ripples on water. This experiment highlights the profound strangeness of the quantum world and forces us to reconsider our basic assumptions about space and time. The rules of quantum mechanics are not confined to isolated particles, but extend to larger, more intricate systems as well. The behavior of electrons surrounding an atom's nucleus, for example, is governed by these quantum principles. Rather than orbiting the nucleus in fixed paths like planets, electrons exist within clouds of probability, occupying regions where they are most likely to be found. It is this probabilistic model that provides the foundation for understanding how atoms, and therefore all matter, are formed. But you might wonder how these abstract concepts relate to the technology you rely on every day. Quantum mechanics has been the driving force behind staggering technological leaps, from the engineering of microchips to the invention of lasers. Without this field of physics, a vast number of modern conveniences that you probably take for granted would simply not be possible. So, each time you use your phone to send a message or join a video call, you are unknowingly harnessing the power of quantum phenomena. Quantum mechanics also introduces us to far more bizarre ideas, such as quantum entanglement, a phenomenon in which two particles become intrinsically linked. This connection means that the state of one particle instantaneously dictates the state of its partner, no matter how great the distance separating them. This reality sparks compelling questions about the fundamental nature of information and how it travels across the cosmos. Looking toward the future, quantum mechanics is more than just a subject of academic inquiry. It is the bedrock of quantum computing. This emerging technology is poised to completely transform our capacity for information processing. Unlike traditional computers that use bits representing either a 0 or a 1, quantum computers utilize qubits, which can simultaneously embody both states. This unique property enables calculations of a complexity and speed that are currently unimaginable. As we continue to probe the quantum realm, it's clear that we stand at the very beginning of a remarkable journey. Quantum mechanics not only revolutionizes our comprehension of the universe, but also compels us to reevaluate our deepest beliefs about reality. Every breakthrough in this area seems to spawn new questions, and each answer appears to guide us toward an even more profound layer of mystery. The field doesn't just inform us about the cosmos. It serves as an invitation to reflect on ourselves and our own position within it. In the captivating domain of quantum mechanics, the idea of a vacuum is profoundly different from mere emptiness. We typically envision a vacuum as a region utterly devoid of matter, a space containing nothing at all. Yet, in the quantum perspective, the vacuum is a turbulent cauldron of ceaseless activity. You can imagine it like a calm ocean surface that conceals powerful currents and teeming life beneath. Such is the nature of the quantum vacuum, a space that appears barren but is, in fact, alive with energy and potential. So, what exactly resides within this quantum vacuum? To a physicist, a vacuum is not defined by the absence of particles, but as a state where particles are perpetually being created and destroyed. This behavior is a direct consequence of the inherent nature of quantum mechanics, where particles can flicker in and out of existence in an instant. It is a constant cycle of emergence and disappearance that defies our classical understanding of what it means for something to exist. One of the most compelling questions this raises is how something can possibly arise from nothing. Within the quantum vacuum, this is not just a theoretical possibility, it is the standard mode of operation. This is where virtual particles come into play. They cannot be directly observed, but their fleeting presence leaves a tangible impact on the universe. These particles are like fleeting shadows of their potential selves, and their brief existence can influence observable forces like gravity or the energy radiated by black holes. The quantum vacuum is also essential to unraveling why our universe contains significantly more matter than antimatter. In the initial moments after the Big Bang, particles and their antiparticle counterparts were formed in pairs. For reasons that remain a mystery, a slight imbalance tipped the scales, permitting a surplus of matter to endure. In this light, the vacuum is not just an empty expanse, but the very stage upon which the most fundamental dramas of our universe have been enacted. Have you ever considered what this means for the creation of particles? On a grander scale, the quantum vacuum can be thought of as the primordial substance from which all subatomic particles condense. When specific conditions are met, such as a particular temperature or energy level, these particles can emerge directly from the vacuum. This transforms the void into a fertile ground for creation, where the right circumstances can give birth to new worlds, much like life springing from a barren landscape after a rainfall. Physicists have devised sophisticated methods to investigate this quantum vacuum, with one of their most powerful instruments being quantum field theory. This theoretical framework provides us with a map to navigate a landscape that would otherwise be entirely alien, helping us comprehend how particles interact with one another and behave within the vacuum. However, it also raises the critical question of what happens when this vacuum is disturbed, as the resulting fluctuations can have a monumental effect on the entire structure of the cosmos. The concept that the vacuum is not truly empty may seem bewildering, yet it is precisely this paradox that makes quantum mechanics so deeply compelling. Imagine sitting in a perfectly soundproof room and suddenly hearing a faint whisper from an unknown source. This is analogous to what occurs in the quantum vacuum. These fluctuations are like whispers in the cosmic silence, introducing motion and life into a realm that once seemed utterly still. Grasping the nature of the quantum vacuum carries profound implications, as this is the very medium that allows gravity to function throughout the cosmos. Without this intricate fabric of interactions, the stars and galaxies you see simply could not have developed as they did. The vacuum, therefore, serves as the grand stage where all the dramas of the universe are played out. Every celestial body, from the smallest planet to the most massive star, is the outcome of a complex dance between creation and annihilation within this seemingly empty expanse. This brings us to the link between the quantum vacuum and the energy of the universe. Far from being a passive void, the vacuum is an active source of fluctuating energy that manifests in numerous forms. According to quantum theory, it possesses a zero-point energy, making it a constant wellspring of power that can shape everything from the birth of galaxies to the expansion of space itself. Every celestial body, from the smallest planet to the most massive star, is the outcome of a complex dance between creation and annihilation within this seemingly empty expanse. This brings us to the link between the quantum vacuum and the energy of the universe. Far from being a passive void, the vacuum is an active source of fluctuating energy that manifests in numerous forms. According to quantum theory, it possesses a zero-point energy, making it a constant wellspring of power that can shape everything from the birth of galaxies to the expansion of space itself. It is truly fascinating to reflect on how all this connects to our own lives. If the quantum vacuum is the fundamental material from which particles emerge, and thus the matter that makes us, then you could say that we are all descendants of this void. Each one of us is a physical realization of the potential held within that apparently empty space. A compelling reminder that reality is always deeper than it seems. So, when you think about the quantum vacuum, remember that it represents not an absence, but a vibrant potential. Deep inside the framework of quantum mechanics, the vacuum is far more than mere nothingness. It is a realm where realities are forged, where creation and destruction engage in an eternal rhythm, and where the key to unlocking the true nature of our universe might be found. Have you ever encountered the idea of cosmic inflation? This theory is as mind-bending as it is vital to comprehending the formation of our universe. Try to visualize the entire cosmos we know, with all its galaxies, stars, and planets, once compressed into a point tinier than a single grain of sand. All existing matter and energy were concentrated in this infinitesimal speck. Then, an event of extraordinary proportions occurred. Immediately following the Big Bang, the universe underwent an explosive growth phase known as cosmic inflation. In a fraction of a second, it expanded exponentially at a rate far exceeding the speed of light. Imagine transforming a single point into a vast expanse in less time than it takes to blink. That gives you a sense of the scale of this event. But you might ask why this rapid expansion is so critical. Cosmic inflation provides a compelling explanation for why matter is distributed so uniformly across the universe. Without it, one would expect a cosmos riddled with irregularities, with massive clumps of matter and vast empty voids. Instead, observations of the cosmic microwave background radiation reveal an almost perfect uniformity, a smoothness that inflation elegantly accounts for. Every time you gaze at the night sky, you are confronted with a fundamental puzzle: the dominance of matter over antimatter. During the inflationary epoch, conditions were so extreme that they gave rise to minuscule quantum fluctuations. As the universe ballooned in size, these tiny variations in density became the seeds for the galaxies and cosmic structures we observe today, helping to explain why the universe developed the way it did. So what role did energy play in this process? Cosmic inflation is also thought to be connected to dark energy, the enigmatic force that is currently causing the universe's expansion to accelerate. After this period of hyper-expansion stabilized, the universe began to cool down. This cooling phase allowed subatomic particles to combine, forming the first atoms that would eventually coalesce into stars and galaxies. Scientists are actively working to verify the theory of inflation through various astronomical observations. For instance, they are studying gravitational waves, which are ripples in spacetime generated by colossal events like the merger of black holes. Detecting specific patterns in these waves could provide the direct evidence needed to confirm cosmic inflation, marking a monumental step in our understanding of the universe's earliest moments. However, inflation also introduces some truly profound questions. If the universe expanded so violently, is it possible that other universes also inflated in different ways? This line of thinking leads directly to the multiverse hypothesis, a concept suggesting a vast collection of universes, each potentially with its own unique physical laws and constants. Picture an immense ocean of cosmic bubbles, with each bubble representing a separate universe. Moreover, cosmic inflation doesn't just explain the universe's past, it also has a direct bearing on its future. If dark energy continues to fuel an ever-accelerating expansion, galaxies will drift further and further apart until they eventually disappear from one another's view. This possibility forces us to contemplate the long-term prospects for life in a universe that is constantly growing more isolated and empty. Reflecting on cosmic inflation makes it clear that this isn't merely a bygone event, but a foundational principle that continues to shape our entire understanding of the cosmos. It challenges us to look beyond our immediate perceptions and delve into the most profound mysteries of existence. With every new discovery related to inflation, we move one step closer to answering the questions that have captivated humanity for centuries. The next time you find yourself looking up at the night sky, I want you to consider the brief, explosive event of cosmic inflation. Within that single moment, the foundations of everything familiar to us were laid. The journey from an infinitesimal point to an immense cosmos brimming with marvels is our own origin story, a reminder that while we may be insignificant against the backdrop of eternity, our drive to comprehend it all connects us to something truly magnificent. Dark matter stands as one of the most profound enigmas in cosmology, and understanding it is essential to grasping how galaxies and larger cosmic structures came to be. Think of the universe as a massive jigsaw puzzle, where you possess all the pieces you can see, but the final picture remains incomplete because a significant number of components are missing. Dark matter represents these unseen pieces. We can't observe it directly, yet its powerful influence on everything we can see confirms its presence. To better understand this, consider being at a social gathering in a completely dark room. While you can only make out the people immediately around you, you are aware of a larger crowd from the gravitational effects they have on those you can observe. In much the same way, dark matter interacts with the visible matter of the cosmos, and without this interaction, galaxies would behave in fundamentally different ways. So, how can we be certain of something that remains invisible? A primary piece of evidence is provided by the galaxies themselves. Astronomers studying galactic rotation have observed a peculiar phenomenon. Stars on the outer rims of galaxies are spinning far faster than the amount of visible mass would allow. This suggests an unseen force is at play, an invisible framework of dark matter that functions as a cosmic skeleton, binding the entire galaxy together. The influence of dark matter extends beyond individual galaxies to the very distribution of matter across the cosmos. Picture a vast spider web, where the junctions of the strands are galaxies, and the filaments connecting them are composed of dark matter. This cosmic web is the reason galaxies form clusters. Without its scaffolding, the universe's large-scale structure would be unrecognizable. This leads to the central question. What exactly is dark matter composed of? It doesn't seem to be made of the familiar atoms and particles that constitute ordinary matter, but rather of some unknown particles that have so far evaded our detection. Scientists have put forward several candidates, including weakly interacting massive particles and the even more mysterious axions, but we have yet to find direct proof for any of them. A helpful comparison is the air around you. You cannot see it, but you're certain it exists when you feel a breeze or watch it rustle the leaves on a tree. Dark matter functions in a similar way. It's an invisible yet critical component, shaping the universe's behavior. In its absence, galaxies would fly apart, and the cosmos as we currently understand it would simply fall apart. You could even think of dark matter as a ghost in a room. Its presence is known only through the disturbances it creates, as it cannot be seen or touched. This intangible quality has prompted many researchers to question if we will ever be able to directly confirm its existence, a puzzle that remains a central focus of modern physics and astronomical inquiry. While dark matter might feel like a purely abstract idea, its implications are incredibly tangible. The universe we inhabit simply would not exist without it, because galaxies could not have formed in the way they did. As a result, there would be no stars, no planets, and no life as we know it, making the study of dark matter a foundational quest to understand our own cosmic origins. This pursuit has spurred the development of highly sophisticated experiments and observatories. Picture massive detectors built deep underground, shielded from cosmic noise, all with the goal of catching a fleeting interaction with one of these mysterious particles. Every potential signal sparks a wave of excitement in the scientific community, though so far, each one has ultimately deepened the mystery rather than solving it. The existence of dark matter also raises fascinating philosophical questions about our perception of reality. If the vast majority of the universe is made of something we can neither see nor interact with, are we perceiving the cosmos as it truly is, or just a tiny fraction of a much grander design? Such questions force us to confront the boundaries of our knowledge and contemplate the fundamental nature of existence itself. As our technology progresses and our grasp of physics expands, the study of dark matter will undoubtedly continue to be a focal point of intense investigation. There is a growing conviction among scientists that we are on the verge of solving this puzzle, which may reveal dark matter to be not just a key ingredient of the universe, but a gateway to entirely new realms of comprehension. So the next time you cast your eyes toward the stars, I hope you'll remember that what you see is not all that exists. There is a concealed cosmos filled with secrets and potential, beckoning us to discover it. With its invisible presence and profound impact, dark matter represents merely the start of a cosmic journey that is still in its early chapters. Dark energy represents another of the universe's most compelling puzzles. To understand it, try to visualize yourself blowing up a balloon. Initially, it expands as you fill it with air. But then, imagine that even after you stop blowing, the balloon keeps inflating on its own. This strange, self-perpetuating growth is analogous to what we observe happening with our own universe. For some time, astronomers have known that the universe is expanding, but the truly startling discovery was that this expansion is speeding up. The cause seems to be dark energy, a strange force that functions as a sort of anti-gravity, pushing everything apart. Our knowledge of its existence comes from studying supernovae, the spectacular explosions that signal the death of certain stars. By observing the most distant of these events, scientists found they were dimmer than anticipated, which indicated they were much farther away, revealing that the universe's expansion rate was accelerating. Dark energy is estimated to constitute about 73% of the universe's total energy. This is an exceptionally difficult concept for us to grasp, primarily because we can neither see nor physically interact with it. While it's often depicted as a type of void that pushes galaxies away from each other, we don't actually know if it is truly empty. It's possible that dark energy is an intrinsic property of space itself, a ubiquitous presence that governs how the cosmos behaves on the largest scales. To help you visualize this, imagine space as an elastic sheet. If you were to place marbles on this sheet and then begin to stretch it, you would observe the marbles moving farther apart. In a similar way, the expansion of space causes galaxies to drift away from one another. The analogy becomes more complex, however, because this cosmic fabric is not merely stretching, it is expanding at an ever-increasing speed. This acceleration is the phenomenon we identify as dark energy. What if I proposed to you that dark energy's influence might reach far beyond the current scope of physics? Some researchers suggest it could fundamentally alter our understanding of gravity. If dark energy is indeed present everywhere, it might change how we perceive the universe's governing forces, potentially hinting at entirely new physical laws yet to be discovered. The theories about it are quite diverse, with some scientists believing it to be a cosmological constant, a term Albert Einstein introduced in his theory of relativity to describe a negative pressure that drives universal expansion. Others, however, argue that dark energy could be a dynamic phenomenon that changes over time. The implications of dark energy are truly profound. If it continues to behave as it does now, it could propel the universe toward a future scenario known as the Big Freeze. In this outcome, the cosmos expands infinitely, causing galaxies to recede from one another until they become entirely undetectable. You can envision a universe where the stars have all faded and a deep, pervasive cold settles over a vast, lonely existence. On the other hand, if dark energy's properties were to shift, we could be facing a completely different fate called the Big Crunch. This scenario posits that the universe's expansion could eventually halt and then reverse, causing all matter and energy to collapse back into a single point of infinite density. Although this idea might sound unsettling, it also opens up the possibility of an eternal cycle of cosmic expansion and contraction. Dark energy also prompts us to ask significant philosophical questions. If this invisible force is what propels the expansion of the cosmos, what does that mean for our conception of reality? This phenomenon serves as a powerful reminder of how little we genuinely understand about the universe. Every discovery seems to open doors to even greater mysteries, which is the essential beauty of scientific exploration. So, as we continue our quest for knowledge, dark energy remains a central puzzle piece that urges us to look beyond what is known. Now, let's address another critical concept: entropy, and why it's so important for understanding the universe. To begin, we can consider a principle that is familiar to all of us: disorder. Think about your room after a week has passed without any cleaning. The state of disarray you would find is a small-scale illustration of what scientists refer to as entropy. On a cosmic level, entropy describes the degree of randomness or disorder within a system, and it plays a fundamental role in the universe's ongoing evolution. The second law of thermodynamics, a core principle in physics, states that as time progresses, the overall entropy of the universe tends to increase. This simply means that things naturally lean toward a state of greater disorder. This principle has major implications for the future of our cosmos. As everything from stars to galaxies is in a constant state of transformation, we are led to consider what happens when disorder reaches its maximum point, where no organized structures can remain. This brings us back to the idea of the Big Freeze, a scenario where the universe cools as it expands into a dark and desolate place. Interestingly, even in the opposite scenario of a Big Crunch, where the universe contracts, entropy would still continue to rise. You might intuitively think that bringing everything together would reduce disorder, but the reality is quite different. During a universal contraction, the interactions between particles would become increasingly complex and chaotic, which would ultimately lead to an even greater increase in entropy. So, whether the universe expands forever or collapses back on itself, the relentless advance of disorder seems to be a constant. But could there be a deeper purpose to entropy? Some scientists have proposed that the rise of entropy might be intrinsically linked to the evolution of complexity and even life itself. In this view, a background of disorder might be a necessary condition for the emergence of more intricate systems. As the universe evolves, complex structures such as stars and planets form against this backdrop of increasing randomness. It's a fascinating thought that perhaps entropy, in some way, acts as the very spark that ignites the creative potential of the cosmos. Given that entropy is at the core of every process involving information, it follows that the two are profoundly linked within the quantum realm. You can visualize this relationship by imagining a jigsaw puzzle.
When its pieces are jumbled in a box, entropy is at its peak, and there is very little coherent information. As you begin fitting the pieces together, however, entropy diminishes, and the picture, the information, starts to emerge.
Applying this concept to the cosmos as a whole brings up some fascinating inquiries. Could it be that information itself is the fundamental counterforce to the universe's relentless increase in entropy? This reveals that entropy isn't merely a principle of physics. It carries deep philosophical weight, compelling you to contemplate the purpose of your life and your position within this immense universe. When you accept that disorder is fated to grow, you must ask what significance your actions truly hold. Are you an agent of that chaos, inadvertently adding to it? Or are you a force for creating pockets of order within the prevailing disarray? In this way, entropy serves as a powerful metaphor for human existence, where you constantly navigate through trials and chaotic periods, yet always have the chance to forge structure and purpose. It's possible that humanity's deep-seated drive to comprehend the cosmos and discover our own place within it is a direct reflection of this fundamental battle against entropy. Every pursuit of knowledge, and each meaningful connection you form, could be considered an act of defiance against the intrinsic disorder of reality. Ultimately, the concept of entropy provides a remarkable lens through which you can view the very fabric of the universe. From its association with the arrow of time to its relationship with information, entropy compels you to fundamentally reconsider your perception of the cosmos and your part in it. As our exploration of the universe's secrets deepens, you might discover that even with the certainty of growing chaos, space will always exist for life, creativity, and connection. In this vast ocean of disorder, only the future holds the answer to what truly lies ahead. The information paradox feels like something straight out of science fiction, yet its consequences for our comprehension of the universe are incredibly profound. What if I propose to you that information is so foundational that it might be the ultimate key to unlocking the nature of reality itself? To begin exploring this captivating subject, you must first grasp what information signifies within the framework of quantum physics. In the simplest sense, information is just any data that you can store, send, or analyze. However, in the quantum realm, information acts in truly bewildering ways. Particle states, for instance, can be so fleeting and erratic that it appears the information defining them simply vanishes. The core of the paradox lies in asking whether this information is genuinely gone forever. The very notion that information could permanently disappear fundamentally conflicts with many of our core assumptions about the universe's operation. Picture yourself standing in an immense library filled with countless books, each one a repository of information. If a fire were to incinerate a section of this library, you would assume the knowledge in those books is lost. Yet, quantum physics suggests that the information somehow persists, even if it's completely inaccessible to you, a claim that has ignited fierce debate among scientists. Physicist Stephen Hawking stands as one of the most pivotal voices in this entire debate. During the 1970s, he put forward the revolutionary idea that black holes could effectively devour information, pulling it past a point of no return. This theory was immediately contentious because it suggested that information could be utterly erased from existence, which would violate a foundational principle of physics known as the conservation of information. How then can you resolve this seeming paradox? One prevailing theory among scientists is that the information isn't actually destroyed, but is merely transformed. Returning to the library analogy, picture that instead of burning, the books were simply transcribed into an unfamiliar language. The information would still be present, just in a format you can no longer comprehend. leading to the idea that it might be imprinted on the faint glow emitted by black holes, which we call Hawking radiation. Next, you have to consider the phenomenon of quantum entanglement. This captivating process demonstrates how two particles can become so interconnected that an action performed on one instantaneously influences the other, no matter how vast the distance between them. This bizarre connection prompts fascinating questions about the very methods of information transmission, raising the possibility that information is not just saved, but shared through mechanisms that are still a mystery to us. The information paradox also carries significant weight for the field of quantum computing. This emerging model for processing data could fundamentally alter how you manage information. By utilizing qubits, which can exist in multiple states at the same time, quantum computers can handle information with vastly greater efficiency. This implies that a true grasp of how information behaves at the quantum scale could open the door to technologies you can barely even imagine today. So what are the personal implications for you? The proposition that information can never truly be lost has the potential to reshape your entire understanding of reality and even consciousness. If every piece of information that defines you is permanently woven into the fabric of the cosmos, it suggests your memories and life experiences might be part of a much larger, interconnected web of data, forcing you to reevaluate your own existence and your place in the universe. As our investigation into the information paradox continues, a compelling question surfaces. Could information be the key to deciphering consciousness itself? Some scientists and philosophers have theorized that consciousness is an emergent property arising from information being processed on a massive scale. This line of thought ultimately invites you to reflect on existence's deepest mysteries, challenging you to reconsider everything you thought you knew about reality, information, and the universe. As our exploration of these questions continues, we may discover that the solutions only open doors to even greater enigmas, reminding us that the quest to comprehend the cosmos is as boundless as the universe itself. The information paradox also compels us to reconsider the nature of time. If information can persist beyond our conventional grasp of space-time, it suggests that the past, present, and future might be interwoven in ways we have yet to fathom, challenging our linear view and hinting that information could be a bridge between different planes of reality. This isn't merely a scientific problem. It's a puzzle that touches upon the most profound aspects of our being. As our comprehension of quantum mechanics and the universe deepens, it's vital to maintain an attitude of curiosity and openness. The search for knowledge about information, its preservation and its function in the fabric of the cosmos, is guaranteed to propel us toward new frontiers of understanding. Ultimately, the information paradox serves as a powerful reminder that the universe is a realm filled with surprises and mysteries. Every discovery inches us closer not only to grasping how the cosmos works, but also to understanding our own place within it all. While a great many questions are still without answers, the pursuit of this knowledge is surely a journey worth taking. But what would you think if I were to tell you that our entire universe might be just one of countless other realities? The concept of parallel universes, often called the multiverse, has long fascinated both scientists and philosophers alike. In this captivating line of inquiry, we will explore how quantum mechanics itself points to the possibility that other universes exist, each governed by its own unique physical laws and realities. Just imagine for a second that every single choice you make, no matter how small, causes time to branch off into a new path. Each decision could spawn an entirely different universe where the outcomes play out in a new way. What if, in one of these alternate universes, You picked a different type of coffee this morning, and this minor deviation set your life on an entirely unexpected course. This idea, though initially a bit bewildering, is the very essence of the multiverse theory. Quantum mechanics, the field of physics dedicated to studying the universe's most fundamental components, operates in ways that defy our everyday intuition. One of its most mind-bending principles is superposition, where particles can exist in multiple states at the same time. Can you even conceive of your own life existing in multiple states simultaneously? In the quantum realm, the possibilities are truly without end. So, how does any of this connect to the idea of parallel universes? A prominent theory in quantum mechanics, known as the many worlds interpretation, proposes that every time a quantum event takes place, the universe itself fractures into multiple versions to accommodate every possible outcome. This means every decision and every event could be generating a new universe, each one living out its own distinct narrative. The very concept of the multiverse also brings up compelling questions about what reality truly is. If countless parallel universes are real, what does that signify for us? Could it mean that a version of each of us exists in another reality, leading a completely different life? To help visualize this, picture a book where each page represents a distinct universe. Every choice you make and every event that occurs is like flipping to a new page, where the story continues along a different path. In this way, life becomes a perpetually expanding novel, with each decision unlocking new chapters and narratives. As if that weren't astonishing enough, the multiverse theory is also connected to other compelling ideas in physics. For example, some scientists propose that new universes are constantly being born from bubbles of space-time. In such a model, our universe would be just one bubble among countless others, all drifting in an infinite ocean of realities. However, the notion of parallel universes isn't just a flight of theoretical fancy. Certain quantum experiments have started to yield results that could be interpreted as evidence supporting the existence of these other worlds. Although we are still a long way from a complete understanding of how it all functions, each new finding brings us a step closer to the truth. Who can say what incredible revelations the future might hold for us? The possibility that we exist across multiple universes also presents profound philosophical questions. If you make a certain choice in one universe but not in another, what does that imply about your identity? Are you a single individual or the sum of all these versions of yourself across different realities? This dilemma forces us to reflect on the very nature of self and how our choices shape our existence. Furthermore, the multiverse concept encourages us to entertain the possibility that other forms of life, with their own unique histories and realities, might coexist within these parallel worlds. What kinds of beings could populate these other universes? Would they face struggles and celebrate achievements similar to our own? Or would they be fundamentally different in every way? Exploring the idea of parallel universes reminds us just how little we truly understand about the cosmos. It inspires us to stay curious and receptive to new concepts, because in a universe where anything could be possible, our imagination is our most essential tool for navigating the unknown. Meditating on this incredible idea makes it clear that science and philosophy are intertwined in the most remarkable ways. Each advance in quantum mechanics not only deepens our knowledge of the universe, but also invites us to question our own existence and the role we play in the grand cosmic scheme. In the end, even though the multiverse theory might sound like it belongs in science fiction, the truth is that with each passing day, we are drawing nearer to solving the universe's greatest mysteries. Each breakthrough in quantum physics and cosmology gives us a new way to see ourselves and our potential. Within this unending quest for knowledge, the concept of parallel universes serves as a reminder that we are intrinsically connected to something far grander and more magnificent than we can comprehend. Have you ever considered that the reality you perceive might only be a tiny fraction of a much larger existence? String theory proposes exactly this, suggesting that everything is composed not of distinct points, but of infinitesimally small, vibrating filaments of energy. But what exactly are these strings, and how might they revolutionize our view of the cosmos? Picture a violin. When a string is played, its vibration creates a distinct musical sound. In a similar fashion, the strands in string theory oscillate at various frequencies, with each unique vibration corresponding to a different elementary particle. This means that electrons, quarks, and all fundamental particles are essentially different notes in a grand cosmic orchestra, all played by these vibrating strings in a higher dimensional space. The notion that all matter originates from these strings can seem abstract, yet its most thrilling implication is the potential to unify the four fundamental forces of nature: gravity, electromagnetism, along with the strong and weak nuclear interactions. Imagine the elegance of explaining the entire architecture of the universe through a single, all-encompassing theoretical model. This is precisely the ambition of string theory: to assemble every piece of the universal puzzle into one perfectly coherent image. So, how does this theory manage to connect ideas that appear to be fundamentally at odds, like gravity and quantum mechanics? For decades, these two pillars of physics have operated in separate domains, each governed by its own set of principles. String theory offers a potential bridge, providing a method to reconcile the bizarre quantum behavior of particles with the large-scale fabric of spacetime that defines gravity. It's like discovering the missing link that finally allows two seemingly incompatible puzzle pieces to lock together perfectly. As we explore this concept more deeply, we come across the captivating idea of extra dimensions. Our daily lives unfold in what we perceive as 3 dimensions of space and 1 of time. String theory, however, posits the existence of hidden dimensions, perhaps as many as 10 or 11 in total. What if these additional dimensions function as unseen passages that link separate realities, offering an explanation for phenomena that baffle modern physics, such as the behavior of gravity at the quantum scale? This possibility presents us with a fascinating puzzle. If these strings and hidden dimensions are real, why are they completely imperceptible in our everyday experience? The most likely explanation is that these extra dimensions are curled up so tightly that they are simply too small for us to notice. Consider a tightrope walker on a wire. From a distance, the wire looks like a one-dimensional line. But for an ant on that same wire, it has a second dimension, the circumference it can walk around. In the same way, these hidden dimensions could be all around us, just beyond the limits of our perception. Beyond just unifying the fundamental forces, string theory opens the door to a universe that is vastly more complex and varied than we have ever imagined. Some formulations of the theory even point to the existence of a multiverse, a collection of separate universes, each operating under its own distinct set of physical laws. This idea challenges our entire understanding of reality, suggesting there could be other cosmoses where gravity functions differently, or where particles possess properties we can't even conceive of. Of course, string theory is not without its critics and significant hurdles. A primary objection from some physicists is that its predictions are exceptionally difficult, if not impossible, to verify through experiments. Yet, isn't this characteristic of truly groundbreaking science? The most transformative ideas in history often preceded the technology needed to prove them. Much like early concepts of electricity or magnetism, string theory may represent a preliminary but vital step toward a more profound comprehension of the universe. This journey into theoretical physics also introduces us to the compelling idea of wormholes. These hypothetical tunnels could serve as shortcuts through the fabric of space-time, connecting distant regions of the cosmos. If string theory proves to be correct, it's possible these passages exist within the extra dimensions we have yet to observe. Think about the implications of traveling across the galaxy in a moment, making light years feel like mere seconds. Such a concept not only excites the imagination, but also fundamentally reshapes our perception of what is achievable. Ultimately, string theory compels us to challenge our assumptions about what constitutes reality. It encourages us to look past our current limitations and view the universe as a vast expanse of unsolved mysteries. The very essence of science is its capacity to grow and transform with new information, and string theory is one of the many instruments we use to decode the secrets of the cosmos. As we contemplate its possibilities, we are left to wonder what other secrets the universe is hiding, and what incredible discoveries are waiting just beyond our current horizon of knowledge. Have you ever had the feeling that there's more to the world than what you can see? This intuition becomes a verifiable fact in the strange realm of quantum mechanics, where one of the most baffling concepts is known as quantum entanglement. To understand this phenomenon, imagine you possess a pair of linked particles. If you send them to opposite ends of the universe and then measure a property of one, you instantly know the state of the other. The connection is instantaneous, regardless of the distance separating them. Imagine that two particles could be connected in such a way that the condition of one instantaneously influences the other, without any physical tether between them. It's as if they share an invisible link that makes distance completely irrelevant. This naturally leads you to ask a fundamental question. How could such a phenomenon even be possible? Quantum mechanics offers an explanation, revealing that particles can exist in many different states all at once. It's only when a measurement is taken that a particle settles into a single, definite state. What is truly staggering, however, is that an entangled particle state is resolved instantly, no matter how vast the gulf separating it from its partner. This has led many to speculate that there might be a layer of reality operating beyond our current scientific grasp. Quantum entanglement directly confronts our conventional ideas of separation and locality. Could it be that on some fundamental plane of existence, everything in the cosmos is intricately connected? This possibility has spurred deep philosophical contemplation about the very fabric of reality and our perception of it. It makes you wonder if our individual experiences are truly solitary, or if we are all part of a shared, underlying matrix that unites our lives. The consequences of entanglement are not merely theoretical. They are already being explored for groundbreaking technological advancements. In the field of communications, this principle is the foundation for developing quantum networks. Picture an instant messaging system so secure that any attempt to intercept information is impossible. A system where your data is shielded by the fundamental laws of physics. This is the promise of technologies that leverage quantum entanglement. As our investigation into this phenomenon deepens, even more tantalizing questions emerge. Could we, in theory, harness entanglement to send information faster than the speed of light? Although contemporary physics imposes clear limits, the human imagination continues to explore concepts that defy our traditional understanding of space and time, pushing the boundaries of what we consider possible. At the same time, entanglement presents us with profound philosophical dilemmas. If two particles can be so intimately linked, what does this imply about our own notions of individuality and free will? It forces you to consider whether we are, in a very real sense, all intertwined within the immense tapestry of existence. These are not merely scientific inquiries. They extend deep into the realms of philosophy and metaphysics. Some thinkers have even suggested that entanglement could have implications for consciousness itself. Is it conceivable that our minds are interconnected in ways we don't yet understand? While these ideas may seem extraordinary, they encourage us to reflect on our own nature and our connection to the universe. In this space, the line between empirical science and spiritual inquiry starts to become less distinct, especially when we contemplate a totally interconnected reality. This quantum phenomenon also fundamentally challenges our perception of time. Within the quantum world, time does not behave as the linear progression we experience in daily life. This suggests the possibility that the past, present, and future might be far more interwoven than we have ever believed. It leads you to question if we could one day learn to interact with this connection in a way that actively shapes our reality. While exploring these concepts, it's crucial to recognize that quantum entanglement is not just a speculative idea. Its existence has been repeatedly confirmed through laboratory experiments. These tests have demonstrated that at the subatomic scale, reality operates in ways far stranger than we could have ever conceived, compelling us to re-examine not only the universe's nature, but also our own role within it. The true beauty of quantum entanglement lies in its power to inspire you. It serves as an invitation to look past the surface of things and to contemplate the unseen connections that bind the universe together. In a world where feelings of isolation are common, this concept acts as a powerful reminder that we are all, in a profound way, part of the same cosmic web. As scientific understanding progresses, the potential of quantum entanglement is set to unlock revolutionary technologies and discoveries. From quantum computing to advanced cryptography, its applications are both extensive and world-changing. This phenomenon not only offers you a new lens through which to view the world, but also propels us toward a future filled with incredible possibilities. We now enter the remarkable world of quantum computing, a discipline that has ignited the curiosity of both scientists and the public. To grasp what makes this technology so extraordinary, you first need to understand how today's computers function. Conventional machines rely on bits, minuscule switches that are either on or off, representing the values 1 or 0. But what if a more powerful method of processing information existed? This is where the qubit, the fundamental unit of quantum information, makes its entrance. The incredible power of qubits stems from their ability to exist in multiple states at once, a property known as superposition. Imagine a light switch that isn't just on or off, but can simultaneously be on, off, and in every state in between. This capability allows quantum computers to process a vast number of calculations far more rapidly than any classical computer. So, how do quantum computers harness this potential to achieve such incredible speeds? The secret lies in the profound interconnectedness of qubits made possible by quantum entanglement. Through this phenomenon, qubits can be so intimately linked that the state of one instantly dictates the state of another, no matter how far apart they are. Think of it like having two coins that, every time they are tossed, land on the same side, whether heads or tails, even if they are on opposite sides of the planet. This entanglement is what enables a quantum computer to carry out many calculations in parallel, creating the potential for breakthroughs that could reshape our world. The promise of this technology is staggering, but it also prompts us to ask what kinds of immense and complex problems it might finally allow us to solve. Numerous industries now view quantum computing as the key to solving problems that are virtually insurmountable for conventional computers. Take, for instance, cryptography, the very foundation of our data security. quantum machines have the potential to dismantle modern encryption algorithms within minutes, which is compelling experts to engineer entirely new methods of digital protection. Furthermore, the simulation of molecular systems is another domain where quantum computing promises to excel, allowing us to precisely model the interactions of millions of atoms, which could dramatically speed up the creation of new medicines and materials with extraordinary properties. However, actually constructing a practical quantum computer is an immense undertaking. The foundational units, known as qubits, are incredibly susceptible to their surroundings, where even the slightest disturbance can introduce computational errors. To counter this, scientists are pioneering sophisticated technologies to preserve qubit stability, often requiring temperatures colder than those found in the vacuum of outer space. This fact alone highlights just how fragile and intricate the quantum realm truly is. This raises the question of when we might expect to see quantum computing integrated into our everyday existence. Most experts concur that we are witnessing the dawn of this technological revolution. Although functional prototypes of quantum computers already exist, their widespread adoption could still be years, or perhaps even decades away. Nevertheless, research is advancing at an astonishing pace, and every minor breakthrough brings us closer to an age where this technology becomes a fundamental aspect of our world. It is truly captivating to think about how quantum computing could reshape not just our technology, but our very comprehension of the universe. What kind of impact will this have on artificial intelligence, or our ability to resolve profound scientific mysteries? The convergence of quantum computing with other disciplines could unlock discoveries that we currently cannot even fathom. It is this curiosity about the unknown that propels scientists forward in their explorations, with quantum computing representing one of the most thrilling frontiers. As we advance toward a future where this technology is more widely available, it's vital that you keep an open mind and prepare for the inevitable transformations it will bring. Quantum computing is not merely a scientific novelty. It represents the promise of a future in which the limits of computation are radically expanded, potentially transforming society. From bolstering our data security to sparking a revolution in medicine, the possibilities are virtually limitless, and we are just beginning this incredible journey. Quantum cosmology emerges at the fascinating intersection of quantum physics and the science dedicated to understanding the universe in its totality. The central question is whether quantum mechanics, the theory describing the behavior of the smallest particles, can also help illuminate the vast cosmos we inhabit. This inquiry is far more than a simple intellectual puzzle. It's a profound attempt to bridge two worlds that, on the surface, appear completely disconnected from one another. To begin, let's reflect on the evolution of our cosmic understanding. In the past, astronomers formulated theories based on naked-eye observations of the heavens. It eventually became apparent, however, that to unlock the universe's deepest secrets, we would require far more advanced instruments. Quantum mechanics offers itself as one of these essential tools, providing a theoretical framework that could influence not just microscopic objects, but also the grandest structures in the cosmos. So, how are quantum mechanics and cosmology related? Imagine a science fiction film where the known rules of physics seem to be suspended, a world where particles can exist in multiple locations simultaneously, and where reality itself is shaped by the mere act of observation. This core principle of quantum mechanics, that observation influences reality, surprisingly carries significant implications for how we comprehend the universe. The idea that the universe originated from a singularity a point of infinite density, presents some truly compelling questions. What transpired in the first few fractions of a second after the Big Bang? It is at this critical juncture that quantum mechanics assumes a pivotal role. The theory posits that during these initial moments, the laws of physics as we understand them simply cease to apply. The universe, instead of adhering to the principles of gravity and relativity, was governed by the strange and often paradoxical rules of the quantum world. One of the most captivating ideas within quantum cosmology is the notion that the universe is perpetually generating new particles and energy out of the quantum vacuum. This vacuum isn't empty in the classical sense, but is instead a dynamic sea of potential. Within this energetic ocean, particles constantly flicker into and out of existence. This leads to the staggering hypothesis that our entire universe might be the product of such a quantum process occurring within the vacuum. When we turn our attention to the expansion of the universe, quantum cosmology continues to provide us with fresh perspectives. The theory of inflation proposes that in a mere fraction of a second following the Big Bang, the universe underwent a period of exponential growth. Some scientists theorize that this inflationary event was driven by quantum effects like vacuum fluctuations, which supplied the immense energy needed for this rapid expansion, ultimately shaping the cosmic structure we observe today. One of the most thrilling concepts in quantum cosmology is quantum entanglement, a phenomenon where particles can remain connected and influence each other instantly, regardless of the distance separating them. This idea forces you to reconsider the universe's interconnectedness. Could it be that galaxies and particles, seemingly adrift in space, are actually woven together by an invisible quantum tapestry? As we delve deeper, we also encounter the principle of entropy, which measures the disorder and energy within the cosmos. Within quantum cosmology, entropy plays a crucial role in the universe's evolution. You might ask how this concept of disorder relates to cosmic expansion and its ultimate destiny. And the answer may be found in the way quantum fluctuations influence the distribution of matter and energy across time. So, what does this all signify for your place in the grand scheme of things? Quantum cosmology suggests that you are an integral part of a phenomenon far more intricate and magnificent than you can possibly comprehend. Every single particle composing your body has a lineage that can be traced back to the universe's earliest moments, a history deeply entangled with the enigmatic principles of quantum mechanics. As our scientific understanding progresses, quantum cosmology confronts its own set of obstacles. Theories that aim to merge general relativity with quantum mechanics are still a vibrant area of ongoing research. The central question that many contemporary physicists are striving to answer is whether they can develop a unified framework that explains both the immense scale of the cosmos and the infinitesimal world of particles. In this pursuit of knowledge, quantum cosmology reveals insights not just about particles and galaxies, but also about the nature of our own existence. It serves as a reminder that within this immense and unpredictable universe, each of us is participating in a cosmic ballet governed by the laws of nature. The marvels of quantum mechanics and cosmology combine to present a vision of reality that is as captivating as it is baffling. Reflecting on quantum cosmology, you find yourself at the crossroads of science and philosophy. It prompts you to ask questions not only about the mechanics of the universe, but also about what it truly means to be a participant in it. Every breakthrough in this field brings us a step closer to solving cosmic enigmas, yet it also underscores that the quest for knowledge is a journey without an end. In every particle, every galaxy, and every corner of existence, there is a story waiting to unfold. The real question is, are you prepared to listen? This leads us to particle physics, a compelling exploration into the fundamental essence of the matter and energy that constitute our reality. This journey introduces us to the smallest, most elementary particles, the invisible foundation of everything that surrounds us. To grasp their importance, picture all matter as an enormous structure. Each brick and stone that forms this edifice represents a subatomic particle. Just as the building could not exist without its bricks, matter itself could not form stars, planets, or even us without these fundamental particles. So, what exactly are these components that make up the fabric of our world? They fall into three primary categories: quarks, leptons, and bosons. Quarks are the essential building blocks of protons and neutrons, which together form the nucleus of an atom. You can think of quarks as the very bricks that construct the walls of our metaphorical building. Without them, atomic nuclei would be impossible. Leptons, a different category, include particles like the electron, which gracefully orbits the atomic nucleus. Without electrons, fundamental forces like electricity, as well as light and all of chemistry, would simply not exist. And what of the bosons? These are extraordinary particles that function as cosmic messengers. The photon, for instance, is the boson responsible for light and for carrying the electromagnetic force. Imagine bosons as couriers, delivering messages between other particles, ensuring that everything in the universe operates in concert. Without them, the forces binding matter together would fail, and the cosmos, as you know it, would descend into utter chaos. Particle physics is also a narrative of audacious experiments and a relentless quest for understanding. From the dawn of modern physics, scientists such as J.J. Thomson and Ernest Rutherford designed experiments that fundamentally altered our conception of matter. Today, this exploration continues inside particle accelerators, colossal machines that look like they've been taken from the pages of science fiction. Inside the Large Hadron Collider, the largest of these accelerators, particles are smashed together at velocities approaching the speed of light. These high-energy collisions recreate conditions similar to those present in the first moments of the universe. In these incredibly brief instants, scientists can witness the birth of new particles, sometimes discovering ones that have never been observed before, offering a new glimpse into the universe with every collision. Discoveries in particle physics have been nothing short of astounding, particularly in the quantum realm, where time behaves very differently from how you experience it day to day. This challenges our linear perception and suggests that the past, present, and future might be far more intertwined than we currently believe. Could you ever learn to harness this connection to shape your own reality? It is vital to recognize that quantum entanglement is not merely a theoretical curiosity. Laboratory experiments have confirmed its existence. These tests demonstrate that at the subatomic level, reality operates in ways far stranger than you could ever have imagined. This knowledge compels us to reevaluate not only the structure of the universe, but also our own role within it. The true beauty of quantum entanglement lies in its power to inspire. It encourages you to look past the surface of things and to contemplate the profound connections that unite us all. In a world where it's easy to feel disconnected, the idea of entanglement is a powerful reminder that, in a very real sense, we are all intricately linked within this immense cosmos. At first, air enters the balloon under control, but the expansion accelerates the more you blow into it. This process mirrors what is occurring throughout our universe. But just how far will this cosmic expansion go? The first possibility we'll explore is known as the Big Freeze, a theory proposing that the universe will simply expand forever. In such a future, galaxies will continue to separate from one another until stars exhaust their fuel, plunging the cosmos into a perpetually cold and dark state, where the starlight you see now is just a faint memory of a warmer time. Conversely, another theory posits that the universe's expansion could someday stop and then reverse. This scenario, called the Big Crunch, suggests that after trillions of years, the force of gravity might overcome the expansion, pulling all matter back together into a single, infinitesimally small point. The universe would then collapse upon itself, becoming an incredibly hot and dense state, much like the conditions that preceded the Big Bang. What would transpire at that final moment is a dramatic conclusion where everything returns to its origin, perhaps to be reborn in a new cycle. There is also a more chaotic possibility, known as the Big Rip. According to this hypothesis, the mysterious force called dark energy, which drives the accelerating expansion, could grow so overwhelmingly powerful that it would tear apart the very fabric of existence. In this outcome, galaxies, stars, planets, and eventually even individual atoms would be violently ripped asunder, leading to a complete and utter disintegration of the cosmos. Imagine being a witness to such an unraveling, where the fundamental structures of reality dissolve before your very eyes. As you contemplate these cosmic fates, it's staggering to consider the timelines involved. We are discussing events that would unfold over trillions of years, a duration that is truly beyond human comprehension. To offer some perspective, if you were to compress the entire history of the universe into a single day, all of human existence would occupy only the final second. This makes you wonder what it feels like to be just a brief flicker of light within the vast expanse of eternity. Our species has always looked to the heavens, searching for answers about our place within this grand cosmic story. Each theory about the universe's ultimate destiny forces you to reflect on your own existence and its meaning. If the cosmos is fated to grow cold and dark, what will be left of our legacy? Will humanity become nothing more than a forgotten echo in an endless void? These ideas challenge our understanding of time itself, prompting questions about whether the future is already written, or if it remains an unpainted canvas. With our advancing knowledge, our questions become more profound. Fields like quantum physics, cosmology, and philosophy are now intersecting in the quest to comprehend what awaits us. The theories we've touched upon represent just a fraction of what science has uncovered, yet the greatest challenge is confronting all that we still do not know. The fate of the universe is not merely a scientific puzzle. It is also a question that touches upon philosophy and spirituality, urging you to value every single moment and appreciate every star that illuminates the darkness. In this immense universe, every individual life possesses a unique significance, a momentary brilliance that leaves an indelible mark. The scientific theories about the cosmos's future are also a mirror, reflecting our own struggle to find purpose and meaning in our existence. So, as you think about these ultimate possibilities, remember that while the end is uncertain, you have the power to make this present moment profoundly meaningful. The universe's vastness and mystery are a powerful reminder that you are here, right now. And that fact alone is an extraordinary phenomenon. Quantum physics has unveiled a realm of possibilities that initially seems to defy our everyday grasp of reality, which raises one of the most compelling questions. What are the philosophical consequences of these quantum discoveries for your life and the universe you inhabit? It appears that reality may not be as solid and objective as you've been led to believe. At the subatomic level, the act of observation seems to be a critical factor, suggesting that your very perception might help shape the nature of what is real. The notion that the observer influences the observed might sound strange. Yet, it is a fundamental aspect of the quantum world. Picture a subatomic particle existing in multiple locations simultaneously until you attempt to measure it, at which point it settles into a single, definite position. This forces you to reconsider the role you play in the cosmos. If your consciousness can affect the behavior of particles, does that imply that you are in some way a co-creator of your own reality? This line of thinking also leads to the question of whether there is a purpose beyond your existence. If the universe operates as a vast field of potential, could every choice you make genuinely alter its future course? This consideration brings you face to face with the ancient philosophical debate over free will. Are you truly making independent choices, or are you merely acting out a script predetermined by the laws of physics? Furthermore, the quantum concept that the universe is fundamentally interconnected implies that everything you do has repercussions, not just for your own life, but for the entire cosmic web. What does this mean for your relationships and your daily responsibilities to others? If each of your actions sends ripples through the fabric of reality, perhaps you should reevaluate how you live and interact with the world around you. Quantum entanglement adds another fascinating layer, showing how two particles can be linked so that the state of one instantly affects the other, no matter the distance between them, inspiring you to see humanity as more deeply connected than you ever imagined. The principles of quantum mechanics also force us to question our understanding of time itself. At the subatomic level, time appears to shed its linear progression, which raises a profound question. What if the past, present, and future are not the separate, distinct concepts we have always assumed them to be? If time behaves so fluidly on a quantum scale, you have to wonder about its implications for our existence and the decisions we make. This line of inquiry pushes us to probe the very limits of reality and our position in it. Imagine if all moments were somehow interdependent, coexisting simultaneously, rendering our perception of a linear timeline nothing more than an illusion. Embracing such a viewpoint could fundamentally alter your approach to life, cultivating a much deeper appreciation for every present moment. The reach of quantum physics goes far beyond philosophical speculation. It compels you to re-examine your very nature and question the essence of the mind and human existence. If our consciousness can indeed influence the behavior of particles, it forces a complete reassessment of our understanding of reality. The intersection of science and consciousness is a rapidly developing area of research, where quantum physics and neuroscience are becoming increasingly intertwined. This convergence leads us to ask if we might one day grasp the mechanics of our own awareness through the application of quantum principles. Yet, these revolutionary discoveries also bring significant ethical questions to the forefront. If your choices genuinely have the power to shape the universe, what level of responsibility does that place upon your actions? This thought encourages a deeper reflection on your interactions with the world and other people. In a way, quantum physics advocates for a more conscious existence, one where you are more mindful in your choices and purposeful in your life. Furthermore, quantum philosophy challenges the very essence of what you know, making you ask whether absolute, objective knowledge is even achievable. If reality itself is a construct influenced by your observations, then the hope of ever comprehending it in its entirety seems remote. This predicament calls for a profound sense of intellectual humility, an acceptance that some answers may always remain beyond our grasp. Ultimately, delving into these philosophical concepts leads you to contemplate the very meaning of your existence. in a universe that appears to be an immense landscape of pure potential. What is your purpose? These questions, while difficult, are fundamental to the human experience in this intricate and captivating reality. Quantum physics now serves as a portal to a completely new conception of the cosmos, urging you to reflect on your life, your consciousness, and your place within it all. The more deeply you investigate these questions, the more meaningful your experience of life becomes. This journey is therefore not merely an intellectual pursuit, but a spiritual one, inviting you to become more conscious of your deep connection to the universe and to everyone in it. The link between quantum physics and consciousness captivates a wide range of people, from scientists and philosophers to anyone with a curious mind. What if I proposed that your very understanding of the cosmos could be tied to the way you think and feel? This naturally leads to a fundamental question. Is your awareness simply a byproduct of your brain's biological processes, or is it rooted in something far more profound? To put it simply, consciousness is your capacity for self-awareness and your perception of the world. But the connection to quantum physics is where it gets truly interesting. A number of scientists propose that consciousness could arise from quantum-level activities taking place within the brain. Consider the possibility that your brain is not just a network of neurons transmitting electrical signals, but is instead a miniature quantum realm where subatomic interactions shape your thoughts and choices. This idea hints that consciousness could be more than a biological occurrence. It might be an expression of the same quantum principles that underpin the entire cosmos. If this link exists, your perception of the world might be far less rigid than you imagine. A key principle in quantum mechanics is superposition, where particles can occupy multiple states at once, leading you to wonder if your mind functions in a similar way. Could your mind hold numerous possibilities in parallel until a decision crystallizes one of them? The idea is thrilling because it suggests your choices are not the straightforward, linear events you perceive them to be. This opens up a vast spectrum of new possibilities for how you engage with the world and with others. Now let's turn to another fascinating concept known as quantum entanglement. This is a phenomenon where two particles become so inextricably linked that what happens to one instantaneously affects the other, regardless of the distance separating them. This prompts a compelling thought. What if your consciousness operates under a similar principle of entanglement? Could this mean you are connected to other people on a much more fundamental level? It is also fascinating to consider how your emotions could shape your perception of reality. We know from quantum physics that the act of observation influences the outcome of an experiment. This leads to the profound question of whether your own consciousness directly molds the reality you perceive. If your mind possesses the ability to affect matter at the quantum scale, then your intentions and feelings might exert a far more powerful influence on your life than you currently believe. Of course, the path of science is never straightforward and is often marked by uncertainty. Alongside these captivating theories, there is a healthy dose of skepticism from physicists who maintain that consciousness and quantum mechanics are distinct fields that should not be conflated. From their perspective, consciousness, while complex, can be fully explained by neuroscience, making appeals to quantum physics unnecessary. An alternative viewpoint emerges from the realm of philosophy, where some thinkers have proposed a radical idea. They suggest that consciousness might not be a product of matter at all, but rather a fundamental constituent of the universe itself, existing on the same plane as matter and energy. From this perspective, consciousness appears not merely as a consequence of brain activity, but as a fundamental component of reality itself, compelling us to ask if it is as elemental as space and time. As we delve into these concepts, we must confront the ethical questions they raise. If our consciousness is indeed interconnected on a quantum level, what does that imply about our obligations to each other and to the planet? This suggests our choices could have repercussions far beyond what we imagine, demanding a greater awareness of our actions and their universal impact. The quest to understand the link between quantum physics and consciousness has spurred the creation of new technologies like quantum computing. As our grasp of quantum principles deepens, we may discover revolutionary methods for interacting with information and, by extension, with our own minds. This naturally leads to a profound question. Could we use quantum technology to better comprehend the nature of our own awareness? It is crucial to acknowledge that while these theories are compelling, our exploration into this domain is still in its nascent stages. Every new discovery seems to generate more questions than answers, revealing a path forward that is dense with unsolved mysteries. The challenge is whether you are prepared to confront these puzzles and broaden your understanding of what it means to be a conscious being. Examining the relationship between consciousness and quantum physics reveals that this is more than a scientific inquiry. It is a summons to explore the very essence of our existence. In the end, the search for knowledge about our own minds may prove to be one of the most thrilling ventures humanity has ever embarked upon. The universe, a vast arena of marvels and enigmas, often leaves us with more uncertainties than certainties, prompting us to question our role within its immense scale and whether everything shares a hidden connection. When we contemplate the idea of a quantum winter, we stand at the crossroads of science and philosophy. This term does more than just conjure images of cosmic chill. It beckons us to investigate the deepest layers of reality. A quantum winter describes a state where subatomic interactions appear to decelerate, almost as if the cosmos itself is pausing for breath.
This concept can serve as a potent reminder that within the grand cosmic dance, a constant equilibrium exists between chaos and order, with every particle and galaxy contributing to a universal symphony. It is quantum mechanics with all its perplexing behaviors that composes the very score for this celestial rhythm. When you consider the universe's ultimate destiny, it's impossible to overlook theories like the Big Freeze, where everything cools into nothingness, or the Big Crunch, where it all collapses back to a single point. Though they might sound like fiction, these ideas are born from rigorous scientific inquiry. These cosmic finales influence our perception of life by teaching us that even though our individual existence is brief, we are participants in a far greater and more intricate process. Entropy, the principle that disorder tends to increase, plays a vital part in this narrative. While this may seem like a bleak outlook for the universe, it can also be seen as an encouragement to discover the beauty in transience. Every passing moment holds value precisely because it cannot last, reminding us that life, much like the cosmos, is in a perpetual state of flux. The information paradox offers a fascinating thread that ties quantum physics directly to our own consciousness, raising the question of whether information can ever be truly annihilated or if it simply changes form. The answer carries immense philosophical weight, for if information is indeed eternal, it could mean that our experiences and memories persist in some manner. This intersection of science and philosophy invites a deeper contemplation of our reality, while the concept of parallel universes further challenges the uniqueness of our existence, suggesting that alternate versions of you might be living out different choices. Similarly, string theory, in its ambition to unite the fundamental forces, reinforces the notion that all things are interconnected.
You can visualize these forces as vibrating strings, their resonance creating a delicate cosmic balance that extends into our own lives, where every action produces a reaction. Understanding this interconnectedness encourages us to be more mindful of our decisions and their ripple effects. At the same time, quantum computing, once a futuristic dream, now holds the power to reshape our comprehension of the universe by solving problems that have long been considered impossible, from curing diseases to developing sustainable energy. As we investigate quantum cosmology, it becomes clear that the laws of quantum mechanics don't just govern the microscopic world, but have implications for the entire cosmos. This perspective invites you to view the universe not as a cold, desolate expanse, but as a dynamic environment brimming with potential, where every star is a testament to the vast unknown. Ultimately, the pursuit of quantum gravity, which aims to reconcile quantum theory with gravity, highlights our human drive to understand the incomprehensible, even as it presents us with more questions than we can currently answer. Our expedition through this quantum winter has led us to confront inquiries that transcend the purely physical world. We have explored the fundamental nature of reality itself, a place where the disciplines of science and philosophy become inseparable. When you reflect on the deeper meaning of these findings, it becomes evident that science and consciousness are not isolated domains but are profoundly interconnected. The field of quantum physics challenges you to reconsider your connection to the cosmos and your very sense of self. Each new revelation does more than simply expand what we know. It brings us closer to a more intimate understanding of our own existence. As we conclude this journey, it is crucial to remember that we are part of a continuous process of exploration. The cosmos remains an unfolding mystery, and as both observers and participants within it, you have the remarkable opportunity to wonder at its magnificence. This reality implores you to continue searching, to persist in asking questions, and above all, to never stop dreaming. The pursuit of answers is a perpetual one, where every inquiry acts as a spark capable of igniting fresh ideas and discoveries. So the next time you find yourself looking up at the night sky, pose these questions to yourself. What secrets does the universe still hold for you? What is the role you are meant to play in this vast cosmic narrative? In the midst of this quantum winter, it's clear that each of us is an indispensable thread in the fabric of the cosmic story.